Hi everyone, in this class let us try to see how to construct 2-bit synchronous up counter, right? So basically if you are trying to construct any kind of synchronous counters, you have to follow a particular procedure, the procedure which you know earlier already. So you have to decide first what kind of flip-flops you are trying to use. So in this particular example of constructing 2-bit synchronous up counter, I am going to use JK flip-flop because in the earlier video I have used already the same kind of example with T flip-flops. Okay, fine. Now after deciding what kind of flip-flop you are trying to use, what might be the second step? Second step is you have to draw the excitation table for it, right? So if you are going to draw the excitation table for JK flip-flop, right? So if I give the present state and the next state, what might be the inputs you are trying to expect, right? Yes, so two combinations, you are going to get 4 possibilities, so 0 0 0 1 1 0 1 1, and the inputs can be in this particular order, right? So you can go through the earlier one, you can get the idea. So this is the corresponding excitation table for the JK flip-flop, right? After that you have to go with the step 3. In step 3 is you have to find out the state diagram for the given requirement, right? What is the given requirement? The given requirement is simply you need to have the synchronous up counter. Up counter means what? You are going to have 0 0 which has to be incremented by 1 and 1 0 and 1 1 that will be replaced with 0. So this is a kind of state diagram for it. Then you have to write down the excitation table for it, right? Excitation table for the circuit diagram. So the excitation table is you have to take out the present states. The present states are Q1 and Q2 or Q2 and Q1. The next states can be Q2n and the Q1n, right? So if you take the possibilities, so 0 0 0 1 1 0 1 1 are the present states. So what might be the next states? So for 0 0 you are going to get the next state as 0 1, right? 0 1. If I give the present state as 0 1, I will get the 1 0 as the next state. If I give 1 0 as the present state, I will go through the next state as 1 1. If I give 1 1 as the present state, the next state will be 0 0. I hope you got clarity, right? Yes. After this you have to go with the excitation table for it, right? So here the excitation table we are trying to construct for JK flip-flop, right? So J2 K2 and J1 K1, right, as they are a kind of flip-flops, right? In the earlier video I have clearly explained why we are going to take this kind of procedure, right? Yes. So to decide J2 and K2 values, you have to go with the Q2 and Q2n, right? So if it is 0 0, what you have to do? You have to have 0 pi. If it is 0 1, you have to have 1 pi. If it is 1 1, it should be pi 0. If it is 1 0, it should be pi 1, right? Similarly, to write the values of J1 and K1, you have to take out the Q1 and Q1 next, right? So you can note down directly, right? So 0 1 means 0 1 means it should be 1 pi. 1 0 means it should be pi 1, and 0 1 means it should be 0 1, right? So 0 1 means it should be 1 pi. Very good. If it is 1 0, it should be pi 1, right? I hope you got, right? So this way you have to write, right? This is the corresponding next step, that is step 3. Coming to step 4, you need to simplify these expressions. For the values of J1, K1, J2 and K2, right? If you are going to simplify it, see, if I try to simplify the J2, if I try to simplify the J2, I will try to take Q2 and Q1 in this order only. So J2 is 0 1, so for 0 0 it is 0, so I need to consider these three, right? If I consider these three, so 0 1 0 1, okay, so except 0 0 remaining all are going to be considered, right? So in remaining all are 0 also, you have to take for 0 1 it should be 1 and remaining 2 will be pi pi, right? How can we combine? I can combine these two. If I combine these two, you are going to get J2 equal to Q1. J2 equal to Q1. Similarly, if you try to find out the K2, so here it should be Q2 Q1 0 1 0 1 0 1. So except this combination of 1 0, you have to fill all the things, right? So for 0 0 it is pi, for 0 1 it is pi, for 1 1 it will be 1, and here it will be 0. It will be 0, right? So if I take here K2 value, if I take K2 value, it will be this is pi, right? It will be again a kind of Q1. Okay, K2 is Q1. Fine. So if you take again J1 value, you are going to get 1 pi, meaning that it any order if you fill, you are going to get the J1 value as 1, guys. I hope you understood, right? Similarly, if you take the K1 value also, in any order if you are going to fill, you are going to get the K1 value also 1. Yes, fine. So once you have drawn the expressions for it, let us go with the logic diagram for it, right? So basically you have to draw this diagram. So if you take the first one as J1 and K1, J2 and K2, and for both of these we are going to have some negative edge triggered clock we pass directly. So I can make it as now synchronous counter. This is synchronous counter, right? Now what you have to do, how to connect this, right? How to do this one, right? So for J2 and K2, what values you have to pass? See, this will be the Q1, this will be the Q1 bar, Q2 and Q2 bar, right? So for J2 and K2, you have to pass the Q1. Pass the Q1. For J1 and K1, you have to pass the value 1. Right? And you can make a note of this as output at the section Q1 and Q2. This is the corresponding circuit diagram for 2-bit synchronous up counter, guys. Okay, I hope understood clearly. Thank you.